Okay. Hello, everybody. Can you hear me? Look at the trade. Okay, good. Thank you. Yeah, welcome everybody to this subject, and thank you very much for joining us, especially for some of you who are now outside Australia and maybe in a time zone where now it's very early. So yeah, we start here, but I think we still expect some participants to join. Give it a few minutes. Is Anchen here? Hello.
Hi, Jun, I'm here.
Yeah. Using this few minutes, I introduce our teaching assistant, Anchen. Anchen, could you raise your hand so I can let you to be a co-host of the session?
Sure. Yes.
Anchen, yes. Give me a sec. Yeah, you are here. Make a co-host. Yeah.
Oh,
So the session works like that. I'm the lecturer and the coordinator of the subject, and I will deliver this the online session to you. And Anchen will be our assistant. So he will help me to organize the class and attend the chat room, the chat board. So if you have questions, you can post them by chatting. And Chen, please, first, help me to look after the waiting room. The session has been set up that you need to log into your UTS account to join, but if you do not, you will be put in the waiting room, and our teaching assistant will let you in. But because I'm talking, I maybe sometime I neglect that, so please help me. Second, Anchen, at every session, please help me to check the recording is going on. And this is to everybody. Our sessions are recorded. So therefore, for first, you can review the session later at a later time when it is convenient. And when during the session, you might find some point maybe that has some difficulty or not so clear, it would be a good idea to take a note about the time when the point was mentioned, and later to come back, have a look at the recording. Yeah, so Anchen, please make sure the recording is going on. Sometimes maybe I ignore that, or sometimes the automatic switch on does not work as intended.
Okay, no worries.
Yeah. And thirdly, sometimes, very rarely, maybe I would encounter a very unfortunate system crash or internet interruption. In this case, hold the session, let it go on, and I will join. I will join back as soon as possible. Yeah, do not just go away. Fine.
Okay. Yes.
So yeah, I think now it's maybe 4 or 5 minutes into the session. Let's formally start. I will express my very welcome to all of you on our board, into this very interesting journey to the exciting field of machine learning, which is one of the core components to build artificial intelligence. Okay, I introduce myself. My name is Jin Li. I'm a senior lecturer with School of Computer Science. And I'm offering this subject to you. I hope we can enjoy a good time together. Now I'm sharing my screen. Let's see how things work. Stop sharing this and start sharing my screen. Share desktop. Which desktop should I share? Desktop. Do not disturb. Good. Can everybody see my screen? Thank you. Okay. I just have a glance at the chat board. Don't worry about the quiz. We will have time to do that together today. And I will talk about that very soon. Okay, our topic today, please forgive me. I probably cannot just play the slide in a presentation mode because if I'm doing so, Zoom is always giving me a hard time to set up the screen sharing. But I think hopefully the phone is the size of the letters is enough for everybody to read. If you cannot, raise your hand or tell that to Anton or put just in the chat board. Okay. Yeah. And anyway, you see, I'm not the best maybe slide maker for presentations, but hopefully I can deliver all the points clearly. So in today's lecture, we have two main topics. First, I will introduce this subject, what you can expect to learn from us and what you are expected to do from us. Okay, that is about the subject. We will spend quite amount of time to introduce the subject, and of course, we will touch the contents during doing so. And secondly, we will informally or informally introduce you the subject, the topic of machine learning. What is machine learning, which is the first topic of this subject. So that is our plan. Okay, how the subject works. This is not introduced in order. On the other side, I introduce you with the most interesting points according to my experience with previous students. Okay. First, when you stuck somewhere, how to get help in this subject. So let's have a look at our sorry about that. Have a look at our Canvas site. And if you navigate to the modules, there is a get started component. Okay, and here we have some topics that you can find the schedule here. You can, this is a university side message about the general help. And about this subject, there are two main threads, two main collections of topics you can find help. The first one is in the FAQ. Basically, we summarize those very frequently asked questions from previous students and we collect them here. Well, you can find the first one is how to find help, and our contact details, and about the programming language, about everything that was very interesting to previous people. And here is a live discussion. So this is the topics going on, and you can find there are a lot of questions asked and answered. Okay, so if you want to ask a question outside the class time, maybe the best place to put your question, if it's not about privacy, is put that in the discussion board, because that is attended more often. And for questions asked there, we have in mind that we are helping not one people, but a lot of people browsing or having a look at those questions. So we will try to provide as much information as possible. And you can see the answers here is not as formal as in the FAQ. Hopefully that is more friendlier to your questions. Okay. And FAQ discussion, and for the online materials, which means you can find some extra learning materials online, which is very rich, considering how hot the topic of artificial intelligence has been in recent days. So there are a few good resources I would like to recommend you. One is an online course on machine learning, and the other is a book which we have been developing this subject based on. Well, we will discuss those stuff maybe later, especially when you give me some questions. Okay, and another very important thing I would like to clarify at the first is, okay, there is a communication protocol when you try to email us. This is the most a lot of issues that has been in this respect. Please, when you ever need to email us, include subject code and your student number in your email, and always start a new message for a new issue or whatever. Never try to reply an announcement message that will be ignored. Okay. And there are also consultation hours. There are 4 sections of the consultation hours. If you navigate to the schedule, you will find them. So I provide 2 consultation hours. You may notice that there are 2 sessions of this subject. One is on Wednesdays, one is on Fridays. The Wednesday session is for postgraduate students, but following the 2 hours of that session, I offer 1 hour of consultation, and that consultation is for everybody. You can join that hour. The session ID is shared with the previous one, but it does not matter too much. You can just join that session. The second consultation I offer is on Thursdays, but that is for booking only, which is here. Can you, this is always an issue. Can you see now? You must can see my mouse. Okay, mouse pointer. So you need to book a slot for this session. the booking is through Google Spreadsheets. So see, this one is for the next week, and I will add pages on this spreadsheet. And there are 2 other consultation hours. One is still on Wednesdays, following my one, which means on Wednesdays we have a whole 4 hours. The first 2 are sessions for the postgraduate students, and the third one is my consultation hour, and the second one will be offered by Gitas, who is an excellent tutor as well. But he hosts his own Zoom ID, Zoom session. You need to join another ID. And there another one offered on Thursdays, following my book only session, hosted by Ancheng. Ancheng is a very experienced developer in this and a researcher in this field as well. So if you have questions, please, you are welcome to join those online interactive sessions. Okay. Hopefully, this gives you much confidence that you are supported in learning. Oh, by glancing at the chat board, I found some very good stuff like Stack Overflow. Yeah, fine, that's very good. So, and I understand when it is get to the subject, the most important question is how to pass. Okay. You need to do 3 assignments. The first one are quizzes. Those are 3 points quizzes, which will be offered during the class. And I understand there are a lot of queries, confusions in the first few weeks. So those quizzes will be available during the session, during the online session, maybe a little bit earlier, but they will expire later in the week. I think they will expire on Saturdays. Don't worry about those tests. I assure you, the answers, the questions and answers will be discussed before you are encouraged to take the quizzes. Okay, and from week 3, the time for the quizzes will be limited within 2 hours after the end of the online session. So, and the policies of get exemptions of the quizzes has been stated in the FAQ. Please do read them. We usually do not offer reseating the quizzes outside the class time. As been stated in the subject outline, quizzes are offered in class. They are in-class tests. Okay, don't worry about the questions. Worry about, please take the quizzes from time to time. If you take them, the chances are you will get the marks. They are very low-hanging fruits. Okay. Assignment 2, that is for you to implement an algorithm and write a report about it. So if I'm talking that this way, it's a bit vague, and we will consider the motivation and requirements of this subject a little bit later when we discuss the contents in this subject. A3 is different from undergraduate and postgraduate students. It's about reflection on your learning. So for undergraduate students here, that is, you will be assigned 3 random questions from A1, from those questions that you have already studied, answered, and maybe get points. and you write your understanding, your reflection on those questions. Okay. So let me get a thing. In the next, I will shortly talk about what we will learn in this subject. So, well, before that, let's give a first example of how the subject, I mean, in the class will go, but I don't know why it, okay, yes, it works. I will launch a poll. You can see that from time to time, I will stop and yeah, and see how things go. Because I understand that I'm not the best person, especially I'm a non-English speaker. So sometimes, especially in this online mode, I can get confused and people get confused. We better to stop time from time, see, let's get the vast majority of persons on board. Okay, good. So looks like we are good to go. And because now we have only 3 people need help, you might just type your questions in the chat board, and I try to address them on spot. I have one question that about the quiz 2. Don't worry about the quiz 2. I will redo that because it has been published prematurely by the system. So we just reconstruct the quiz. If you miss submit something in quiz 2, don't worry about that. Okay. Yes, you do get the marks straight away after the quiz. But because in the first 2 weeks, the quizzes will expire on Saturdays. So it is not that straight away. You need to wait for a few days. I will publish the slides after this session. Yes, the quizzes are on Canvas. Okay, let's go. All right. Topics. Why not? I'm using the. Let me just use my draft of the topics because that will make things much clearer. Okay. Now you can see we have a roadmap of this subject. They are color coded. So don't read about the contents, consider the colors. For the white ones, we introduce general topic about machine learning. And for the green ones, we will introduce specific algorithms or specific models. But
sir, can you zoom in a little bit?
Yeah, but as I said, for now, just look at the color of the nose. I will zoom in and introduce the contents. Okay, so for the yellow ones, we consider the why questions, why things work this way or that. the theory part, theoretical part, and the motivational part of the subject. And now let's introduce one by one. For this week, we do what is machine learning. So I will briefly introduce a very rough definition of the machine learning, and perhaps just use example questions and encourage you maybe ask questions. Let's get a good idea about what we will study in this subject. And we consider when to perform machine learning. So basically, it's that like when you get into your career and you are facing some situation. We are engineers. We want to get things work. Okay, and machine learning is just one weapon from our arsenals to attack those questions, those difficulties, and when it would be a good idea to employ machine learning. After that, we will consider the how question. If I decide to do machine learning, how machine learning works, what are those essential elements in the machine learning system? Okay, and in that section, in that class, we will introduce a general framework that will cover the majority of the following discussions about the technologies, theories in this subject, a general mind framework. Okay, although it is a specific one in a more generic machine learning field. And then we will discuss one particular machine learning model, which is a perception. And perhaps the most intuitive model. You have observations which are represented in, of course, in numbers, because you are using digital computers to do the learning. And with those input numbers, you want to get some conclusion. And let's see, the conclusion is very simple. It's just the 0, 1, positive, negative, binary conclusion. You have two choices. You want to choose one from your input. And how to do this in the most intuitive way. And you will find that the style of this subject is different from the style you perhaps have learned in the previous data analytics and other subjects, because I taught those subjects before as well. So the style here is focused on the underlying, the under the cover mechanism, how the system has been constructed and why it was constructed that way. We try to study those questions. On contrary to how to use this model. If you want to just know how to use this model, no, this is just a tiny little bit of what we will touch. Okay, and that is the reason in assignment 2, you need to implement an algorithm from scratch using programming languages and write a report about the steps. Okay. As we touch this topic, let me state that from the very beginning. We will discuss assignment 2 later, but one question that has been very often asked, let me address that now. We do not check the duplication of your implementation in your algorithm. So we understand that there are just limited ways to do things precisely technically. So if your code is very similar to others' code, actually, I will provide you example code to do assignment 2. So don't worry about that. We don't check duplication about that. But we mark your assignment mostly on the report. We will check how you have understood the algorithm and the challenging the algorithm and the solution to them. Okay. And we spent 2 lectures on perception. The first one, we introduced the model, how to construct the model, how it was motivated. In the second one, we that is a more a deeper one. Technically, it's more difficult. But for this subject, you can try to go through those difficult or technical points. But if you cannot, don't worry too much. That is to give you a taste of in real world how, when we design the machine learning model, how we can be confident that the model works. This is to show you a typical way of building machine learning models and verify them. So in this the fourth lecture, we will try to understand why perception algorithm we will introduce in the previous week is expected to be working. Okay. I got some questions in the chat board, but I will pause from time to time. Okay, let me address them later. And for the simple ones, yes, the lectures will be recorded and uploaded later. In the next week, we consider another family of machine learning models. You probably have already learned that decision trees in the introduction to data analytics, which is a prerequisite of this subject. And we will follow the similar approach as the previous ones. So basically think about that. You have always used a software called KNIME, right? So when you build models, you have some nice nodes represented as little icons of different models. Here, you drag the nodes into your workflow, and then, boom, you have a model. Yeah, and how it works behind the scene in this process is what we will learn discussing this model. And in the next, we'll touch a theory that is very related to the building of decision trees, especially particularly the one we will study, and which is information theory. And information theory is way beyond that. It is ubiquitous in a lot of different topics in machine learning. We will consider that. This is a bit technical as well. And then I mentioned the introduction to data analytics. If you have learned that subject, you will learn the first principle to distinguish training and test. If you do not do that, you will fail that subject. That is one of the most important marking criteria we adopt in that subject. And in the lecture here, we address why. Why it is so difficult, so important to distinguish training and test. Okay. After that, I think we have climbed most of the difficult terrains in this subject, and the rest of the landscape is promising. So move that because I have two awkwardly arranged screens, and the Zoom just give me more trouble. Good. And in the next, we consider two composed and more powerful but more useful machine learning models. One is ensemble, and the second one is neural networks. We will spend 2 lectures in neural networks. Okay. Well, so we will consider those topics in more clear when it comes to the lectures. No. Are we good to go? Nice. Seems that I'm doing a good job now. And very well done, everybody. So there is one person need help. You can yell your help right now because you are the only one. So,
Hello.
yeah.
Can you hear me?
Yeah.
Yeah, just quick question about the quizzes. So it's saying that in weeks 1 to 3 or maybe 4, the quiz is gonna be due on Saturday, right? But after that, when it's gonna be exactly due? So just a bit confused about this part.
It will be in class. In class means the quiz will become available in class. Usually, I will set the time as 1 hour into the class, and then it will expire after 3 hours. So you have 3 hours to do that, but you only need something like 15 minutes. It's okay. So as long as you participate in the class and have an interactive discussion with us, don't worry about that.
Thank you.
Okay, let's move to the next topic. Clear that, clear. Okay, and I think I have covered this slide. You have a look. I am not a great presenter using the slides. So, but don't worry. When it comes to things that you really need some written notes, I will use a very old style Blackboard way of taking the notes. So yeah. My slide isn't great, I have to say. Are not great. So, this is how you work with online learning materials. So basically, let me just talk through that. It's very easy. We have modules. Please be reminded, the modules are organized with according to the topics they touch. But it is not necessarily we do one topic per week, such as when we study the first machine learning model, we will spend 2 weeks. And for the machine learning problems, we will spend 2 weeks. Okay, so how you organize your study? I will publish the learning materials for the next 1 or next 2 weeks during the semester. And when you get have a look at the learning modules, you go from where we stopped previously. And for the first one, we do not have previously studied anything. You start from beginning until you reach the code exercise of the week, the next code exercise. Look, online workshop 1, and here is a code exercise 1. Then you study those parts for the first week. But the first week, admittedly, is very simple. So it does not matter if you haven't previewed them too much, and I will guide you shortly. And after this lecture, for the next week, you start from the practical examples, go through all the way to code exercise 2. Okay, that's the plan. So basically, this is what has been discussed here. And the next big topic I want to talk about is computational tools, which is Python here. I know a lot of people have already nowadays have already got experience about Python, but let me give you a brief introduction about the most confusing notions and some to clarify things a little bit for the Python part. Okay, let me get it. Okay, so I believe most of you already know what programming language does, right? You have a computer where okay, it appears good. You have a computer here, okay, which can do computations. And you want to talk to the computer, give it instructions about, look, this is a task, do that thing. You need some translator, okay, which translates your human language, your expression to something that the computer understands. So that is a programming language. Programming language allows you to express the instructions in a convenient way to let the computer to execute. And Python, the language is at this level, which is a common sense. In this sense, it's no different than like C or C++ or Java or whatever. Maybe the only distinctive characteristic of Python is it's very easy to learn. I mean, it makes the life of you easier. I have a lot of questions addressed to me, like what should I use, like PyCharm or this my handwriting. You will find PyCharm or MS Code, Microsoft VS Code. A lot of things. I found one use Vim. That's good. Okay, those things are editors. They are not the translator for you. They are just a word processor to help you to just save your program. Those are called IDEs, interactive developing developing environment. So it just provides you convenience. You give instructions to Python, Python translate to the computer, computer spit out some result, and those guy take the result and show that to you in a good looking way to make the life easier for the developer. Okay, so this is how Python works. Python is like a backend, and those are like front end. If you think that in a way how website works, and then comes the question: what is how about the tools we choose to use? We choose to use the Google's Colab. It is like a computer on cloud, runs Python. The Python is on cloud, and the front end, how it interacts with you, is just your browser, any browser. So it is just to give you a convenience of setting up the Python programming environment and automatically give you a convenient IDE without you need to install any software on your computer. You can just use your browser as you do internet surfing. Well, then there is another set of conceptions like scikit-learn. You will encounter this from time to time. I remember in Python it's there is a shortcut for that. It's called scikit-learn, and PyTorch, TensorFlow, stuff like that. Those are libraries, and libraries are pre-programmed, a collection of pre-programmed subroutines or functions that when you are giving instructions to Python, you can, instead of express out a lot of complicated algorithm, you can just call that, okay, I want an algorithm that has already been implemented somewhere. Please help me to find them. And we choose to use Python for a reason that for machine learning, there exists a great community that has been helping people to build a large number of state-of-the-art algorithms. So for the vast majority of things you want to do in machine learning, if you choose to use Python, its library will probably already contains what you want to implement. Okay. So although this is just a subset of the concept about Python programming, actually this contains almost all the tools we will need to use. So particularly for this subject, we for machine learning in general, if you get to the basic basic things boils down to very particular operations. What is that? You need to multiply two strings of numbers one by one, pairwise, and take the sum of it. It is like if you have numbers 1.5 minus 0.5, 1.2. And maybe you have another set of numbers such as 0.5, 1.7 minus 5. You take the multiplication of that. And you add the result together. Of course, for people who still have some memory about linear algebra, I avoided to mention those technical terms in case to switch you off. But that is nothing more than this is essentially the same as the inner product of two vectors in linear algebra, which is the core of all computations. Well, that is might be an exaggeration, but well, mostly of the most important computations in most machine learning algorithms. And there are very nice people back in 1916, okay, grandfather people. They have implement routines to do those kind of basic operations very fast. And they utilize the optimization in the CPU to make the computation we used well, back then, they do not have idea of machine learning because machine learning wasn't there at the time. But it's just that those computations is ubiquitous in scientific field. They implement very efficient subroutines programs to do those computation. And later, their implementation, their libraries was adopted everywhere, anywhere. And when Python was introduced, some good people, they implement a wrapper of their library. Their library is called a very, very technical name, Basic Linear Algebra Subroutines. Okay, BLAS. And people implement very convenient interface. So from Python, you can call libraries that implement BLAS protocol. So that library is called NumPy. And this protocol, the BLAS protocol, was very widely adopted in the scientific world. And before that, you have MATLAB, just to help people to call this. And it is behind R, the computation in R as well. Of course, R will use that for another set of functions, but the core computation, a lot of core computation, is just to multiply numbers and add them together. Well, so a lot of Python libraries built on top of NumPy protocol. They might not just call NumPy, they are not a wrapper of NumPy, but they will implement very similar interface of NumPy. Basically, if you learn how to use NumPy, the learning curve for you to learn other libraries would be very easy. Okay, so I'm talking at this question, and then later, a little bit later, well, I'm touching a very different topic. People find one thing, if you play video games, okay, in video games, the most important thing is to draw things on screen. Everybody who play video games, you will get this very specific idea. Frames per second is how fast your computer can draw pictures on your screen. And how to draw pictures on screen? You have three-dimensional models, and the models are expressed in triangular meshes. And the computation to do that is you need to take the vertices of those meshes and project them on screen. You need to figure out, well, on each pixel of the screen, which corresponding point on the three-dimensional model it is. And you need to consider the lighting sources. You have the lights, and how the light reflects on that pixel and reach your camera. So it turns out this computation is mostly to multiply numbers and add them together. And keep in mind that for a computer to draw a picture, it needs to do the same thing for each single pixel on your screen. And therefore, you need to do this thing very fast. But fortunately for the computer graphics, it is like that. usually when you have figure out the basic operation at the basic level, the computation on one pixel is mostly independent from the computation from other pixel. You can compute the color of this pixel, and independently you can compute the color on the other pixel. So therefore, clever people invented a way of to do that. You can batch process the job. You delegate the job to a device called graphic processing unit, GPU, which is not very great of processing logics. If you like the GPU, okay, look, please do an if-then jump, things like that. It's not good, but it's very, very efficient to crunch numbers. Okay, and then very clever people find it might be a good idea just utilize this mechanism to do the linear algebra computations above. Okay, so that is called the GPGPU, generic purpose graphic processing units. Nowadays, nobody call that. People just use GPU. We no longer use GPGPU, as we no longer call computers electronic computers. Okay, so anyway, then it's only natural people find maybe we can re-implement the BLAS using GPU computation, and that is called cuBLAS. Cu for CUDA, and that is a GPU computation tool by NVIDIA. Every game player knows NVIDIA, right? Okay, then we ramp the computation using some very nice library. That is in early days, the TensorFlow only support cuBLAS and PyTorch, stuff like that. So that comes the neural network computational libraries, because that operation is especially important, essential in neural networks. And of course, those libraries offers other facilities for us to implement neural networks, but that comes later in the subject. So here is a slightly lengthy but might interesting story about the Python ecological system, and hopefully that will motivate you to learn machine learning using Python. You can expect that will pay you back in a long way in your career. Okay, so now we are getting to the our topic, I think. Are we good to go? Probably I need to grab a glass of water, but well, this this class is slightly earlier than expected. Okay, sure. Now let's start study machine learning. See, very nice. I still keep a lot of people on board. We consider the what and the when questions. what is machine learning and when to do that. Okay, so recall that in the beginning of introducing Python, I said programming language, and what you need to do with that is to instruct the computer to do things. So basically, that is kind of an instinction for computer science and IT guys. When you want to perform some task, you write a program, you instruct the computer to do that. Okay, this is like an instinction for us. And what is machine learning comes into this business? Okay, I always like to start this using this meme picture. Machine learning. That there is a point. Of course, there is a point in this meme picture. Let's talk about that. Sometimes machine learning is called software 2.0, which if you try to discuss that officially, is to improve the productivity in the IT industry and blah blah. Well, but if you consider the story behind that, okay, for some task, it is inconvenient, it is difficult, it is nearly to impossible for our human programmers to specifically instruct the computer to do, and therefore we take the lazy way. We show computers examples. Look, guys, this is how you are expected to behave. We show them examples, and hopefully those very hard studying machines learn from the examples and program themselves, which, yeah, sounds too good to be true, right? Okay, so how to do that? And that is, and when to do that and how to do that, that is our question. How to build a machine that programs itself? Okay. Before considering this question, let me show you another meme. No, maybe not another meme here. I'm okay. Let's consider a very intuitive situation I have introduced you when we are considering. Remember that first lecture, what is machine learning? Second lecture, how to do machine learning, a framework. Third lecture, the first example, when I'm introducing the first example, I say consider a situation that is simplest. You have a couple of numbers. Just take it a couple. Maybe you have two numbers, 1.5, 1.2. One example, two numbers. Second example, 1.4 minus 0.7, two numbers. Okay, and you need to make decisions about those examples, positive or negative, positive or negative. And according to this meme-like problem setting, what the teachers do, you do to the computers. You show them those examples, and the computers need to find a way that will map, will transform. See, in your example, maybe let's see, this is positive, this is negative. Okay, your computer need to find a way so that 1.5 and 1.2, and this is to go to positive, and 1.4 minus 0.7, this is to go to negative. Okay. What you are designing is you design a structure of this transform. You do not design the details of this transform because that is for the machines to learn solve. You design the structure of the transform. It is like in your DNA, it does not encode what the memory a baby will have after being born. It just designs the basic structure of the brain of a baby. Okay, the neurons need to go this way and that way. Here is an organ called eyes, and there is an organ called ears. You take inputs from those things. You connect the signals from the eyes and ears from those neurons, and then you wires up the whole brain. But on the specific settings of the wiring up, like when the signal from the eye is going this way and then fire neurons, no, this is to be learned afterwards. So you design the structure, not the details in the structure. Here is a very intuitive design of the structure. Okay, so like maybe this is the symbol I want to make, decision I want to make, and let's just call this input 1. Let's call that input 2. Of course, I want the information from the input to the output to go through. The very intuitive way is let's give them 2 weights. Okay, maybe I need to give it a multiplier of say 10, and this guy is less important, or somehow I give it a multiplier like minus 0.1, and we take the sum of that, and then look, I got the multiplication and then take sum right here. We take a sum of it, and then we consider the summation, the result, and threshold it. If it passes the threshold, get positive. If it's below the threshold, get negative. Very intuitive. So you design this structure of that, and in traditional way, you need to pick up those numbers to give specific instructions to the computer to do things. But in our software 2.0, you give the computer the generic design of this mechanism, but you do not pick the details of the design. How to do that? Okay, here is another meme. Look at it. So there is a brutal and brain-dead solution to the problem. I just want my guy go here. You can try to randomly change the details in your structure until it works. Well, it is a very unassuming, not very promising solution, but it is a solution. And so this is how the meme says. If you randomly change that stuff until things work, you are performing very bad behavior and you get fired somehow. On the other hand, if you can do this stuff quick enough, it's called machine learning, artificial intelligence, and you get 4 times pay. Okay, let's try to get things more profitable. So this is the machine learning problem and what we want to solve. Structure, we learn structures, and we want to learn the methods to efficiently adjust, modify the details in the structure so that things work as expected. Okay. So this is the introduction of what is machine learning. Are you good to go? Most of you are still with me. I'm very happy. So this is still on what is machine learning. I'd like to give you these examples, but we do not have that much time today. If you'd like, somehow we will touch those examples from time to time. If you'd like to discuss more, maybe join our next office hour. So in the next, we consider when to consider machine learning. So you can say that machine learning is not some mysterious thing. It's not a holy grail. It's not like a thing you write into your slides to present to your investors. This is not the thing we are talking about. Machine learning is specific to or a tool set contains a lot of tools to help us address problems. And when those tools will be the efficient, the wise choice for a problem. Okay. There are 3 conditions. The 3 conditions is where I have plagiarism derived from the short course I mentioned above. I will publish this this slide and you will see the book, which I find is very useful. First, data. Okay, software 2.0 is to get the performance of the machine on some task based on experience. For a computer, the experience is nothing other than data. So with data, we are in business. Without data, no machine learning. But here is a distinction I'd like to let you know. You know, those are always those little details here. So here is a distinction between machine learning and artificial intelligence. You can think machine learning is a particular way of building intelligent machines. intelligence is more than learning. Some artificial intelligence, some intelligent systems can be built based on rules and a way of cleverly exploring the rules. Consider one example of chess. If you set up the board and the game rules for computer, chess or poker or stuff like that, those systems can work without data. Of course, the boundary is blurred nowadays. Those systems built upon rules and data, like AlphaGo. But that does not exclude the possibility of you just build an intelligent system, maybe not perfect, but it's based on just the rules, exploring the rules without using data. And that is one school of artificial intelligence, and that is not based on learning from data. So we focus on machine learning. And you can find in this subject, I think in your study plan, the subject is called machine learning, but if you are postgraduate, the subject is called advanced data analytics. And there is a reason there are two interchangeable names to the subject. We need data to do machine learning, okay? The second one is an interesting one. It's called, it needs more explanation. You need to reasonably expect there are learnable patterns in the data, okay? So there are trends, there are intrinsic connection between two parts of the data. One part is where you observe, and the other part is where you want to predict in future. There are some pattern. The pattern needs to be to persist over time, and that is called generalizable patterns in the data to perform machine learning. And thirdly, there needs to be some challenge. So it actually, I would like to call that half of the condition. It's not like you need the challenge to do that, but what I'm trying to say is you need the challenge for the performing of machine learning to be economically reasonable. Okay, see, and also the the boundary is blurred. I will give you examples to talk about. I will show you examples. But before that, let's consider the pattern first. Sometimes I was muted myself, sorry about that. Sometimes I find it's beneficial to talk about the third and the second and the third aspect together. So let's consider patterns and challenge in machine learning. See if we try to predict, for example, the weather in, say, Melbourne. I draw that very roughly. So if let's to be specific about our goal, we want to predict whether there will be raining in Melbourne in next 24 hours. This is a yes or no question. And consider we collect the data in the surrounding area from Melbourne. Okay, we organize the locations in a grid from a grid of locations. Maybe we get the air pressure. See air pressure 1, air pressure 1, 2. Stuff like that. Maybe humidity at those locations. Maybe wind speed, wind speed U, wind speed V, because you actually it's wind velocity because wind is a 2-direction thing. You collect all those, you have a large array of numbers. So you have maybe 10,000 numbers. And historically, you get, see, this 10K has been collected, see, 4th August 2020, and the outcoming of raining or sunny comes out on 5th. So let's label the data. Let's tag the data using the final date. Okay, so historically you have a lot of such recordings, maybe long time away. So you have this big chunk of data. And although obviously it's very difficult to find specific link between these two quantities, but you can reasonably expect there are some trend could be discovered from how the information on the left part is connected to the outcome on the right part. This is a positive example where I see you can reasonably expect there are patterns in your data. Okay. On the other hand, consider the other task. See, if you turn to astrology, so rather than using the neighboring areas measurement from a meteorologist's recommendation, instead, for the same set of target values, you try to record, see, where is Venus in the sky? Where is Mars? Okay, sorry, Mars is outside Venus. My fault. Where is Mars in the sky? And where is Saturn in the sky? You take the record of those heavenly bodies. Okay, there is no denial that you still we would still be able to make a record of those like weather and the positions of the heavenly bodies in sky. We can have this set of records, right? But could you reasonably expect to establish some trend from this kind of data? You get the question. Think in your mind. Think about it for a while. Obviously, many of people will think, no, this looks not right. You probably cannot get the trend of data. I won't believe that in the first place. Of course, when the situation is explained clearly or as plain as this is obvious. But dangerously, unfortunately, the fact is, if you try hard enough, this set of data using a powerful machine learning model, the model can deceive you. It can cheat you into believing that there is some trend in this set. It can behave as you instruct it to behave. It is not the machine learning models. It is not the machine's responsibility to check the sanity of your problem setting. It will just try to crunch the numbers, and as any good pupils, the little kids do, following the instructions of teachers, if you force the model into producing the prediction using the input, it will do so. Okay, so there is not much guarantee that apparently a good behaving model will generalize. For a model to be able to generalize, you will hear this word from time to time. Generalization, that is vitally important in this subject, more important than anything. You do all the efforts to perform some task. What you want to ensure is your effort is not in vain, it's useful. Okay, that is the slightly deeper discussion about you need to reasonably expect there is persistent patterns in your data. And continue using our heavenly body example about the economic part. So machine learning model needs to be useful. It is considered to be useful when you do not have a mathematical description of the process you want to model. If you are facing a thing that there is an explicit solution mathematically, physically, you probably want to try to apply those explicit knowledge first. See, it probably will not be a good idea. See, this is our star sun. and this is Mars. And what you want to predict is where about of Mars in an hour. So this is probably not a very good application scenario for learning. You have explicit equations governing those heavenly body, how they runs. Okay, then you just evaluate your equations rather than adopt learning-based method. But as I said, when you study that a little bit deeper, the boundary becomes blurrier and blurrier. It's not that clear. See, if instead of considering only Sun and Mars, you have, see, Earth here, Venus here, then you have a full body problem. And instead of consider it surrounding in 1 hour, you consider it surrounding in 1 billion years. Maybe for 1 billion years, you will not have explicit position. You might want to consider whether this will collide with Earth or something. Then you will find to explicitly integrate or evaluate the Newtonian equations becomes, well, difficult. And somehow you may have observations of ancient planet system, stuff like that. Well, then learning becomes a viable solution. And consider the fact that how the equations governing those heavenly body was discovered in the first place. Okay, you get into the figures like Galileo or guys in his ear. Then there is a quote from Galileo, but I do not remember the exact words. But the essence of Galileo is that do not try to argue how the heavenly body was governed, which I think Galileo was referring to against some religious debate. Galileo said the important thing is to explain the data. So you need to explain your observation. So perhaps their first intention is to build mathematical or simplest mathematical models to explain the observation of the data of those process, and then they establish the modern physics. So a classical physics, sorry. Here are our discussion about what is machine learning? Software 2.0. The point of that, okay, for something that is inconvenient to program ourselves, we let the machine to program themselves. To program the machine, we let the machine to program themselves. When there would be a scenario that is so good but not too good to be true, for us to conduct this business, you need to have one, data, two, some good sense that there are discoverable trends in the data, and three, things are really difficult to program directly by yourself. If you can program it, program it. If you cannot, try data. Okay. So here is what I'm going to deliver today. These are your take-home points. So before discussing more, let me relaunch Pro 1 and see how things goes. And then we will discuss quiz 1 before I let you to try it. Okay, I give you 1 minute to consider about that, and you let me to grab a glass of water. Thanks. Okay, sure. Looks we are good to go. Yes. Quiz 1. Okay. These are not accurate. You do not have 99 attempts anymore, because if I will set up like that, but then it will take some great efforts for the quiz to give you your results. Anyway, does not matter. It's I will show you how the quiz works, and I think. Where I have two screens. One screen just cover the bottom of another one, and so it feels a bit awkward for me to find the start the quiz. Yeah. Maybe you come here. Okay, much better. Is the text readable? Yeah, thanks. Good. I will discuss quiz, but please notice one thing: the answers will be shuffled from one person to another. So do not just copy my selection on my screen. Your answer might be in a different order. Which is the following is not a key element in learning from data. Okay, so in predict models, and that is supervised machine learning, there are different branches of machine learning, and in this subject we will consider the most straightforward, the first natural setting up, which is supervised machine learning. But the discussion above extend to almost all kinds of learning from data. First, existence of some relationship between the observable variables. That is just means what you can observe. It is like the left part we have put here, observable variables and the target of prediction. You need this, but the question is not a key. So don't choose this. This is needed. Observe the data from the process of interest. You need data. Data is one essential part. Okay. Mathematical equations. Mathematical equations that exactly describe the relationship between the variables. No, you do not need this. If you have this, probably you do not need to perform machine learning, as we discussed. So question 1, this is the solution. Okay. Question 2. Which of the following statements about learning is correct? Okay. This contains a little bit technical part. I want to remind everybody here. In supervised learning, observed data samples consisting okay, wow, my English consisted should be. The data attributes and the target values are necessary in both stages, the training and the testing, which means when you perform learning, you have examples as we have put it here. Remember when we discuss here, we see, okay, the teacher gives examples to the machine and you need to have some sanity check about whether there are trains in the examples. Okay. You train the machine, but after the machine has been trained, you need to, the machine will after it's, sorry, not this way. After it's trained, see, if you have a weather reporting machine learning model has trained, in future, the machine will observe the nearby meteorological measurements of the atmosphere, the ocean, the land. But the machine will not have the target value. If it has the target value, there's no point to do forecast. Forecast means you try to talk something about the future for which the information is not available here. So in the test stage, the target value is not available. The target value is not available while testing. Okay, this is incorrect. In supervised learning, the training samples represent the exact relationship between the data attributes and the target values. This is incorrect for a number of reasons. See, the measurement of the process we are interested in might not be accurate. Even in the ideal world, there is some exact relationship between the variables you want to take as input and the variables you want to predict, even if there is some exact relationship. But when you really try to practically establish the model, you may not be always able to observe, to take the exact value of the observations. The observations may always contain some noises, inaccurate measurement, inconsistency, broken sensor, stuff like that. And that is a practical aspect. And theoretically, you may not be able to take all the relevant input variables at all. See, in the weather prediction example, if you want to predict the weather, and see, in a very ideal world, you can measure the humidity, measure the wind, measure whatever to the exact value, and your sensor never your sensors never breaks a break. But how? But then, so what? You need to take the measurement at location 1, and you take the measurement at location 2. You never know what is happening in between. Everybody heard the concept of a butterfly effect. See, how about if there is a butterfly flips its wings in between your measurements, okay, and then somehow affect the final outcome of the weather. So in almost all practical problems, the relationship between the data attributes, the measurement, the observed variables, and the target values are not exact. We will never expect it to be exact. Okay. So excluding the first two, if you just want to take the quiz, it must be the third one. And I read that out, and I will spend maybe whatever left time to explain that after the questions already. The relationship between the attributes and the target is say represented by an F. Let's call whatever we have discovered in machine learning model called F. And that option states that F must accept all legal samples from space X. That means for whatever input, F must generate some output. F does not have the right to reject some input. Okay. Obviously, in the practical applications, as a programmer, as a developer, you not only have, you should add some sanity check. Okay, this sample looks like corrupted. But here is talk about that theoretically. When you build a function, when you build a map from the input space to the output space, this map you need to consider over the entire input space. And this is not a good thing. It's not like, as I said, you should not try to accept everything. But this is the way things be. When you build machine learning models, your model inevitably covers the entire data space X, and it is your responsibility to consider this coverage in your mind and try to somehow mitigate its behavior somehow. We will discover this a little bit later in more details, but now choose this. Okay, question 3 about logistics about this subject. I just give you the right answer. From next week, I will have each quiz, I can attempt each quiz twice, and the higher score will be recorded. So if you have multiple trials, the higher score will count. Each week, I will have a handout of a Python notebook. The problematic thing in this is I should start working with the code and the learning materials during the online session. No, it would be too late. You should start working before the online session. Okay, so you get a warm up. The point is not, of course, for you to learn everything, and then I will be unnecessary. The point is you get your unknown stuff to be from the unknown unknowns to be known unknowns. You know where is the problem. You know where you stuck. So you come to the online session, you get a very efficient, effective learning experience. And this one is correct. This one is incorrect. Similarly, this during online session stuff here is incorrect. Okay, this is the old numbering. Last year, we numbered the week as orientation, then week 1, 2, 3, 4 to 9. But in this year, we just name them like week 1, 2, 3, 4 to 10. So just choose this from week 1 to 10. We will have marked quizzes, and these are the part of assignment 1. Okay, the quizzes will be given during the class. This one, don't choose it. You cannot pass the subject using the GUI tools such as KNIME or Excel without programming. It is very unlikely. As we have discussed before, the point in this class is to show you what happens behind the scene when you drag a node from the node repository in KNIME onto your workflow. So boom, that is up and running. And the point of this subject is to study what makes that up and running. So you cannot pass that without touch the undercover stuff. Okay, so look, even with this really slow motion, there is enough time for the quiz. So I just submit now. Okay. I understand. When you submit that, it will withhold your result for a while, but because now you know what the correct answer is, that does not matter too much. The points will show up after the quiz expires tomorrow. Okay. There will always be 3 questions. Yes. Let me confirm 3 questions. Yes, I think so. Yes, yes. Are we good now? Okay, looks nice. Okay, we have 5 minutes left, slightly into the data space. Well, that concept sounds a bit abstract. The data space and the technical stuff. Okay. So from now on, and from time to time in this subject, I will illustrate, I will draw the business, the work, as if we are dealing with no more than 2 numbers. Okay, you have 2 observations, and you try to answer some questions from the 2 observations. But keep your mind, I try to remind you from time to time, that works way beyond 2 numbers. I draw 2 numbers because I can only draw 2 numbers. Okay, so if you have data in this plan, if you have 1 here, that means it has 2 attributes. One is x1 at this value, and the other is x2 at this value. So usually you would have something like this. See, plus and negative. And your your task is to build an F, and F will bring this part of the data space to plus and bring this data to negative, and that is the task. What the question was asking is, okay, as long as you define F, like it or not, F will produce result here. F will produce result here, everywhere, not only limited to where you have observed. Okay, and that is what it means. And look, in our main topic, supervised learning, the samples are given tags, little tags, minus, 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 positive, 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 when we record them. And F's task is specific, give a positive and negative number for the data. There is another branch of machine learning called unsupervised learning. And unsupervised learning is more difficult than the supervised learning. Why with one less element it's more difficult? It's because the data does not have these small labels, which means the questions that would be asked in future is not so clear when you observe the data. It's like someone just threw you a bunch of data and say, okay, learn something about that. And well, you'd better to learn them well, because later, well, I will ask questions about the data. And you ask what questions you want to ask and what aspect you want me to focus. And that person said, no, I don't know for now. Let me think about this in future. So that create a more difficult task for you to the supervised learning. And you just want to build like a model of the data to answer questions like what's trained in the data in future. Okay. And there is another branch which is called semi-supervised learning. Or non-surprisingly, some of the data points have tags like positive, negative attached to them, and some does not have. So what's the business of semi-supervised learning? Remind yourself that the F, like it or not, need to produce values everywhere on the capital X. Okay, and unsupervised learning gives you some hint, gives you some information to help the supervised learning in such a way that it tells you, look, I have some data, although we do not have labels there, but it tells you whereabouts of the data. Okay, if you have limited power, if you have limited learning resources, concentrate on your correctness, on your regularity, on the areas. Although I do not have labels, but I tell you those areas are where counts. I can forgive you of behaving wildly, maybe outside those data distribution. Okay, that is the point of different kinds of learning. So with that, we finished this lecture. We have 2 main points: how subject works, and that has 3 sub points. What you can expect to have help, what is expected from you, and how to study the subject using the online learning materials. Second, the first topic of subject. Okay, what is machine learning? Software 2.0. You are lazy, let the machine program themselves. When this thing too good and is not too good to be true, which is good. First, you have data. Now we are in business. Second, you can expect some extensible, some generalizable patterns in the data. And the third, it is really challenging to program, so that you do not program. If you can program, you program. So that's the point. Okay, let's do the poll for the last time before I'm letting you go. How do you how are you thinking of this lecture? Are we good to go? Okay, thank you very much. And if you need help, you know where to get help. Please come to the office hours, and I will see you
Sir,
next
I just
week.
have a quick question.
Huh?
Yeah, so for the so today we finished until the quiz 1, and for the rest of the module 1, that is for next week, or we have to do it like at home for self-study or something?
It's for the next week. You just browse them. There is no requirement for you to do much thing about that. And from the next week, I will try to give you some hands-on experience about using Python. Maybe easier than that. From next week, I might give you hands-on experience about how to use Python to automate a process that is illustrated using Excel. So don't worry too much if you cannot get too much penetrate into Python. We will guide you.
All right, so yeah, thank you.
Bye-bye.
Just quickly, John,
Uh-huh.
is there any tool, like do we have to use Google Colab, or can we use any tool we want for the implementation?
The requirement is you can use any tool, but you need to. I will talk about assignment 2 in week 4 or week 5. I think the rule of thumb is you need to guarantee like the markers can execute your code and access your data as yourself. If you do this, anything is okay.
And then the other question I had is, what are some recommended online courses for people who are learning Python for the first time?
Learning from Python, there are 2 very good online material providers. One is Udacity and the other is Udemy. But for the basic stuff like Python, I think Udemy is very useful. But that is only for systematic learning. If you have experience such as programming with Java, C, or C++, you probably do not need to systematically learn Python from scratch. It would be like reading the English dictionary, which is a little bit dry. You can pick up Python along the way you are learning machine learning. And there had been a very helpful recommendation in the chat board. Will you ever get any error message, any questions, any problems, you try to describe that specifically, especially when you get some error message. You copy the error message and Google that. And after you Google that, fortunately, almost always, Google find a result from Stack Overflow. You go to Stack Overflow and probably you get the answer there.
Okay, thank you.
Okay.